So this means that you have not, you are not able to, yeah, most of the students, I mean that it's for everybody, you are not able to get the results. So let's go to the second point where we would like to come. Okay, there are few students, those who have not replied, please reply. Okay, 6 students have not replied. Anyway, I'm going to the second question. So let me have the second question in the meantime, which is about your so I'm just putting all the questions visible. So some of the questions were not visible, or all questions were visible to me. So I'm just asking you guys that, okay, some problems in displaying questions in MST1. So all the questions I have, what we have seen that some of the students, they were having some problems. The students were not able to see the questions, no? And that's why I think the result is delayed. Okay, some of the questions were not visible. Okay, for 25 students, all of the students, everybody reply please, that we have exact number, what we are talking about. Okay, so majority of the students, they were having problem. This all the questions were visible and there was not any problem. सर एक एग्जाम ही नहीं हुआ प्रभजोत कौर. Okay, so some questions were not visible. So there are many. Only one or two questions have problems. Problems only displaying problems. Okay, not the conceptual problems. No, I'm asking only about the displaying problem. No? Okay, so I think yeah, that's the reason. That's the reason why we could find about. Okay, so I would like to share the responses with you. Okay, so 35 students are saying that everything was right. All the questions were visible. Some questions were not visible to 6 students. Only one or two questions have problems, 7 students. And one student is saying that even one exam not held. Okay, I don't know why it was not held. Okay. So yes, that's thing. Let's okay, go to the next question. Okay, next question is about, okay, secret, I will not speak it. I will ask some difficult question. I expect that honest answer from you. Okay, so you can just but be honest to answer this question, and remember that I'm not asking you guys to okay reveal something or giving you allegations. Only thing is that my idea is that okay, online exam, does it make a difference for you? So let me project that question about cheating in online MST. Yes, it was easy to do from internet. No, there was no option, no scope to cheat. We and try to post the honest answer. Okay, it's not nothing to do with your career or you are disclosing. I'm just checking that if online if system is effective or not. Okay, so please do not. I'm not asking have you cheated. Be careful. Okay, I'm not asking you have you cheated, and I'm not a person right person to check that if you have cheated or not. Okay, so from that point of view, please send your vote. Okay, we can take help from each other. No, so I think the options are somehow misread. That students are there was no scope to cheat, and if you tell me the correct thing, then it would be helpful. No, I know that you won't give me right answer because I have not asked from you that if you are able to cheat or not like that. No. Okay, anyway, we would like to, we can take, okay, I think the 6 students, those who are saying I'm showing you the results. We can take help from each other, 6. And one student, it was easy to, okay, so let's see that who is the student who is saying this one, and we would like to give some reward. Muhammad Wasim, Muhammad, okay, Muhammad Wasim, okay, and we can take from here these 6 students, okay, because here the those who are saying no, they are important. No? I mean that those who are saying yes, it was easy to do, or they can take, they are important because it's not a problem. Okay. Okay, anyway, we are not asking about you, no. Okay, because I understand that everybody from MSc physics, they are honest people. Okay, so yeah, that's not a problem. And I think in your case, it would be like we have done enough practice, so that would not be compulsory to cheat, no. Okay, so let's begin our discussion here, that what we were doing and what were the things which we would like to do from here. So yeah, so if you recall what we have done in our last lectures, that would be one thing, and thereafter we would like to point out about this the things which we have. So let's share screen. Just pulling a new screen for you guys. Okay, so we would like to have your screen sharing option. So we are sharing right now the screen, and here we would like to point out something about the topics which we have seen so far and how important these topics are. So if you recall what we have done, we have started with the LEED, and in this case, in case of the LEED, what we have done, we tried to fix up the problems that how the electrons diffract this case. And the overall aim is that if you have a certain piece of sample, what you are trying to do, you are trying to eliminate that piece of sample with the help of the incident electrons. And that was entire story. And after that, what will happen, that your electrons, they got scattered from the surface of the sample and they are detected by the detector. So that was the entire story. The basic principle is electron diffraction, and we have to make it sure that we are talking about the electron diffraction when we are talking about LEED. So what is the essential difference between the scanning electron microscope and the LEED instrument? So in case of the scanning electron microscope, what you do, that you have secondary electron emission. Okay, and here you don't have any secondary electron emission, but what will happen, that okay, you would have scattering of the electrons. Okay, and when you have the scattering of the electrons, you will decide that these scattering which are coming out, are they interfering constructively or destructively. So that the basic principle, if they are interfering constructively, in that case what will happen, you would be able to see that you have a broad spectrum of the scattered electrons which are interfering constructively. So that's the main aim of ours in this case. So if you would like to come to this and the topics which we would like to discuss today, so let me come to that point what we are talking about one by one. So here we have this what we are going to talk today. First thing which I would like to talk about is the Ewald sphere. Instead of talking about Ewald sphere, I would like to come to the pattern which is there. Okay, so let's say that okay, LEED pattern, and then the second thing would be, then first is this one, and the second thing which we would like to discuss is the Ewald sphere. Okay, and probably if we have time, then we would like to come to the this difference between lead and RHEED. Okay, so these are the set of the topics which we would like to discuss today. So let's have a discussion on these topics. So we have these topics to discuss today. Okay, so let's have a look at this thing which is there, okay, about the lead pattern. If you recall, then what we have done in the case of what kind of the pattern do you have in case of the lead? So you would have the pattern. Let's say that if I am pointing out this some of the points, then in that case, what I will do, that you would have the 2D lattice, and what you are trying to do, you are trying to make the pattern of this 2D lattice. Okay. Okay. Let's say that this one. Okay. In 2D, what will happen, that you will see. Even it would be better that if I open some PPT for you guys. Okay, and only thing is there, what you would have this, let's say that the this is the lattice parameter A. In that case, let's say one of the primitive vectors. In that case, if you would like to plot this pattern, in that case of the lead, what you would have, you are trying to get this pattern like this, no? Similar pattern. But I would like to make them the pattern which is there. So let me fill it out. Okay. Okay, so let's pull out the stuff which you have. I don't know if it takes longer than expected. There is some problem in this software which I'm sharing with you right now, so I have to turn it off my whiteboard. Let's, yeah, that's the problem. Let me force switch this application and reopen this. Okay, I have to reopen this paint. Okay, I have this one right now. Okay, so what we are trying to do, the first case which we were thinking in this case, that you would have, okay, so several points which are there, and let's say that, okay, we are just making these points in this case. So what we would like to say, that here you have these points. And if you would like to, let me pull out just a minute. I I'm just pulling out stuff for you. Let me pull out the stuff. I'm pulling few things for you. So let's have a question time so that you are not. Okay, you can answer this question. In terms of basic principle, there is no difference between SEM and LEED. Okay, so we have answers. Let me share these answers with you. 8 students have not replied. Please reply. I'm sharing the responses with you. So any one student can reply in the chat box who is confident about the option. Very confident, 100%. One student can reply in the chat box. So 17 students are saying yes, and 30 students are saying no. So should we go with the majority or minority? Yes, please. Yes. So the correct option is no. That's what I am teaching you, that here in the case of the scanning electron microscope, what happens? You would have the electrons which are the secondary electrons which are responsible for getting the images of the sample. And here it is the electron diffraction. Diffraction is a different phenomena. Secondary electrons emission is a different phenomena. So you have to make it clear in your mind that these are two different setups. No? So the basic principle of the two setups is entirely different. One, in case of the SEM, you would have the secondary electron emission. In case of LEED, you would have the electron diffraction, which is responsible for getting you the information of the surface structure. Okay, okay, so we would like to pull up one thing for you, so that this one. So I'm sharing screen again with you guys, and here we would have this information about the LEED pattern which we have. If you recall, this is the basic principle, and I'm showing you typical setup here, that how does a LED optics or a machine looks like, no? That we have to make it clear that how does it work, no? So if you look at the option which you have here, okay, what is the LEED optics? You have a sample from the electron gun. You are directing the electrons onto the surface of the sample, and then this is the detector grade which is there. So you are getting the electrons detected. It's not the detection only, but it is the constructive interference of the scattered electrons in this case, no? So that's we can view that with the help of the TV, and the pattern looks like this one. So what you would have, the pattern which is there on this surface of the screen, which is a fluorescent screen, that would be a fluorescent pattern. And here what you are trying to do, you would have the reciprocal lattice formed onto the surface of the screen. So actually the LEED pattern is the diffracted pattern, which is indeed the reciprocal lattice which we are talking about. Okay, and what you do, that you look at the electron along x-axis, you would have the electron energy. Along y-axis, you would have the spot intensity. Okay, what you are trying to do, you would have this. You would look, for example, if you have this particular spot, you would look at what is the intensity of the this spot. Okay, and what would be at what electron energy you got this the intensity. Okay, remember that. Okay, now question arises that what will happen, that here you would have also, there will be many electrons. Let's say that I'm making them red. Okay, I'm making them red here. Okay, there are also the electrons which are hitting the screen. Okay, but they are not visible in terms of these spots. Okay, the red dots which I have made here, these are also the electrons, but they are not coming into the LEED spectrum. Can you tell me that what is the reason for that? Who will tell it? Any student voluntarily can raise hand and tell us the reason that why these electrons which are here, the red electrons which I'm making them circled, they are hitting the fluorescent screen, but they are not giving you this pattern. Okay, so the answer to this question is that these electrons, although they are hitting the screen, but the problem is that they don't interfere constructively at these points. Okay, here you are looking at this point. Let's say that if you are looking at this point, particular this point, in that case this is due to the constructive interference of the electrons. Okay, so you are just looking at, okay, you can probe the spot intensity and then you look at the electron energy in this case. Okay, this is the commercial optics. Okay, how does it work? And from the inside, okay, in one of the German laboratories, you can see that you would have this LEED optics, which is quite cheap compared to the XRD machines or RHEED machines in this case. Okay? Let's go to the second pattern. So the Ewald sphere construction. Here, what you would have, you would have the Ewald sphere construction for 2D lattice, K and K naught. Then what will happen here? Okay, on the LEED screen, you are getting that pattern in this, no? So you would have particularly the 2D lattice and how this 2D lattice can be mapped onto the surface of the LEED pattern onto the fluorescent screen that we can see in this case. Okay. So here what you are trying to do with the help of the real space, if you look into the details here, then here let's say that, okay, let me pull up one of the arrows. So you would have what you would have, you are trying to pull up I'm pulling up this arrow for you guys. I think it's not enabled. Okay, anyway, I will just try to make manual arrows for you. So you see this one. So here, if you look at the LEED pattern, you have this real space. Real space is the actual space, which is the space of the sample. Okay. And this is the LEED pattern, which is the reciprocal space or the diffracted space. In this case, you can see that, okay, 2 by pi, 2 pi a, if you have the that one of the primitive cell a, that primitive vector is a, in that case it will be 2 pi by a in this case. Okay, same thing you would have here in the case of the second one. Okay, you would have, this is a, and here you are having this the particularly 2 pi by a, the atoms are separated, the interference pattern is separated in this case, no? And only this one is adsorbate structure. Okay, if you look at this, so then these are the basically what you do, that when you are characterizing these materials, you are depositing something over it. Okay, like something is adsorbed onto the surface of the structure. Okay, and this the material that shows this kind of structure. For example, it can also be the moisture. If you have, then you would have the additional points which are there. Okay, extra spots which are there in the this lattice. Okay, and okay, here you see that, okay, if you have the surface point lattice like this one, then LEED pattern, how does it look like? These are, you don't need to go into the detail, but at least if you have a, let's say that if you are talking about a nickel structure 100, then how it will look into the LEED pattern that we can see in this case. Okay, that thing is there. Okay, here I would like to share one of the videos. I think that crystallography, and I don't know if it is visible to us or no, it does not work right now, but maybe yes, that is okay. So anyway, we would like to come to this point here. So we would have this. Okay, we are coming back to our point. Okay. So now question arises that what is the Ewald sphere? Okay. So how do we understand this Ewald sphere? That we have to know from this discussion which we would like to have. So what will happen in the case of Ewald sphere? Okay. What is this Ewald sphere? Okay, we have to understand this. So we are talking about this Ewald sphere, and what we have to talk here, that again I would like to make a few points, no? So that the points are, let me make these points with the help of something. Maybe I can make it like this. No, I can make it like that. So I'm just making few points. I'm making basically 2D structure, this 2D representation, so that it is clear for us that what we are trying to do. again making the same thing here. Okay. So basically, what I'm doing right now, that we are trying to understand that what is the meaning of the word sphere. Okay. Let's say that what is the condition here. If you have a sample, let me draw it quickly so that we have this information in this case. So let's have this information. What we are trying to do, that here what you have a sample, and what you are trying to do, you have an incident electron, and then you would have the scattered electron. So basically what you are trying to do, you are having, this is your source, okay, and here you have your detector, and this is your sample. Okay, okay, this is your sample. So what you are trying to do, let's say that, okay, if you are k vector like this one, okay, and here you have k dash vector, it is the wave vector of the scattered electron. In that case, what will happen, you would have these things which are coming into play, that like if I consider it the origin here, let's say that, okay, this is the point where we are considering the origin of this okay. So then in that case, what you would have, let's say that I'm pointing out from here to here, no? Or just a minute, I'm pointing out this thing from here to here, okay, let's say like this, okay, and then the second thing which I would like to point out is from here to here, no? Okay, at this point. So here, what do you have? The third thing which I would like to point out is from to here, no? Okay. Here, what you are trying to do, that the points which you have. So if you have this point, if I'm saying this is minus k, because I have taken my origin from here, so it would be plus k along this direction. Okay, minus k in this direction. Sorry, it is k. Okay, not k dash. No? Okay, and this is k dash scattered. So in that case, what this vector, which is the delta k, that would be equal to k dash minus k. Okay, so you understood this, that what we are talking about. We have electron. Because what will happen? Okay, you have this sample. Okay, but you have to try to situation which is there. Okay? We have to make this situation with in this case, how do we talk about this this thing which is there? Okay? So what we are to talk about, that we have to point out to this this image which you have, no, is this image. Okay? What you are trying to do here, that the this thing which you need to have here, this k is the wave vector of the incident electron, and k dash is the wave vector of the scattered electron. Okay? So now what will happen if they interfere constructively? In that case, what you will do, that in that case you would have this delta k. This delta k is equal to g. Okay. G. Okay. So what you are trying to do now, you will try to do one thing, that if you change the vectors, no. Now what you have done here, you have this thing here, and you are changing the k vectors. No? So let's see that. Okay, what you are trying to do, you are changing the k vectors. No? Accordingly, what will happen? Your if you are changing the k vectors, okay. So there is some echoing. I should stop your voice. Okay, so we would have this thing. So now I have a new k vector. No? And if you look at this, then correspondingly my k dash will also change, and accordingly my the final one, which is delta k, that will also change. Okay, let's make it clear. So in that case, what you are trying to do, you are trying to make this when you are having these points, no? What you are trying to do, that you are trying to make this type of the thing over there. Okay, so let's see that how we can make it. If I can make it with the help of things which are there. So let's see that. Okay, so right now what we are trying to do, that we have this red circle which we have made. How many lattice points this red circle is hitting? Okay, so let's say that. Okay, but we are trying to find out the points which are being hit in the red circle. Okay, so let's find out these points. You have 1 point, this one, maybe you have 1 point, this one. This is the second point you have hit. This is the third point which you are able to hit. In this case, fourth point, fifth point, sixth point, seventh, 6 points. Okay, so you have, what you have done, that you are able to hit 6 points in the Ewald sphere. Okay, so in the 2-dimensional, of course it is a circle. Okay, but we can easily extend that knowledge of circle to the sphere in the 3-dimension when we are talking about the diffracted pattern. Okay, so the overall aim, what is the overall aim of this drawing this picture? What we are doing right now, we have this k and k prime. We have this k vector, which is the incident wave vector, and then k prime is the scattered wave vector in this case. And if you want to calculate delta k, then it will be k dash minus. Okay, so this k, these are all these are vectors. Okay, try to make it clear. Okay, and when you have this condition which is satisfied in this case, you are talking about delta k is equal to g. Okay, and it will be g HKL, okay, in 3-dimension. What you are trying to do, that this when the delta k will be equal to g, that's one of the questions. Can somebody tell me when this delta k will be g, when it will hit the reciprocal lattice point? Okay, so in the diffracted pattern, what you would have, you have different ways. What you can do, that you have, either you can move the source, you can also move the detector. Okay, so what you are trying to do in the first case, you have tried to move the detector. Okay, let's again come to the point. What you can do, the number one point is that you are moving detector. Okay, what you are trying to do, you are moving detector. Okay, moving detector. Detector. And in the second case, what we are trying to do, we are moving, we can also move source. Okay, or second thing, not only moving source, but we can also change the wavelengths of the electrons which are incident onto the surface of the sample. Okay? And third thing is that what you can do, you can tilt the sample. Okay? Tilt sample. These are the things which you can do here. Okay, so we have time over. Okay, so students are leaving. Let me complete it in 1 second so that I summarize, that it should not go in waste. Okay, so let me, okay, please stay with me for at least 1 or 2 minutes so that we understand in a better way what is happening. We are trying to understand what is Ewald sphere. Before understanding Ewald sphere, we need to understand that what is the meaning of the reciprocal lattice. Okay, reciprocal lattice is a diffracted lattice. Okay, when this is the real lattice, this is the real lattice which is on the sample, and the detector is detecting here. In case of the fluorescent screen, that is the the reciprocal lattice which is being detected. Now what is this problem of the Ewald sphere? What it will tell us, that it will tell us that how many points you are hitting, which are the diffracted points, okay? Those who are having the maximum intensity there, okay? Constructive interference over there, okay? With the help of this one, okay? If you look into this one, then this, okay, what you are trying to, if you are changing the K values, in that case, what you would have, you are trying to change the radius of the circle, okay? If you look at the K, so it is, what is key? K, it is 2 pi by lambda, okay? 2 pi by lambda. So if you, how you can do it, okay? If you want to change the K vector, the wave vector of the electron, in that case, what you have to change the wavelength. And how you can change the wavelength? You can, the energy which is there, okay? The accelerating potential which is given over there, okay? So that can, the energy of the electron, that can change the value of lambda in this case. And in turn, if you are increasing the lambda, in that case, what will happen? K will decrease. If you are reducing the value of lambda, then K will increase. So what you, if you, here you are increasing the value of K, so you would have increased the radius of this Ewald sphere in this case, Ewald circle in this case. So we would like to continue this concept. If you have any question, don't hesitate to talk to me directly right now. Overall, it is the geometrical Ewald sphere is a geometrical construction which is a try to address the issue to find out the points which are having constructive interference. Ewald sphere tells us about the constructive interference points on the photography, this the fluorescent screen in this case. Any question, please don't hesitate to talk to me, otherwise you can leave. Yes, please. Any question? Enabling the sound.